to JMath.
Now we get to the concept of the equation of a tangent. Now you're going to learn about tangents twice in grade 12, once in analytical geometry, so the tangent to a circle, and then in calculus. But this one is completely different. There's nothing that correlates except for the concept that a tangent only touches once. So this is a very easy part if you remember the steps. A tangent is a straight line, so y is equal to mx plus c. Now they're either going to give you an x or a y or a m, and then you must just get the other two. If they give you an x, you're going to find y by just subbing in that x into the original. If they give you an x, you're going to find m by subbing x into the derivative, because remember, the derivative is also called the gradient of the tangent. Once I have all three of those, I just sub it into y is equal to mx plus c, and that's how I figure out the c value and hence the whole equation. Let's do a sum and see how it works in practice. Find the tangent to the curve of fx if 4x minus x cubed is equal to fx, and they give you the x value of minus 1. So I know I want a y value and an m value as well. So now I need to start the process of finding them. To find y, I'm just going to sub in minus 1 into the original formula. So I can, instead of writing fx, I'm just going to write y is equal to 4 times minus 1, and then minus 1 cubed. I know 4 times minus 1 is minus 4, and then minus 1 cubed is still minus 1, and then there's another minus, so this becomes plus 1, and therefore y is equal to minus 3. To find m, I'm just going to sub it into the first derivative. So I'm going to say the derivative of x, I know that is m, and in this case it would be 4 minus 3x squared. So I'm just doing the shortcut, the power rule. If you're unsure of how I got the derivative, please just go and check the video on the power rule. So now I know if that is my derivative, I will find m by making all the x's minus 1 for this specific sum. And that would give me 4 minus 3 gives me just m is equal to 1. So now I know all three of my values, and I can just go and sub it into y equals mx plus c. So y equals, I know m is 1, x plus c, and I can then sub in minus 3 in the place of y, and then minus 1 in the place of x, and that would give me a minus 1 on the right. I take it over and it becomes a plus 1, so that is just minus 2 is equal to c. Therefore, y is equal to 1x minus 2 is the equation of the tangent. Question 2, find the tangent to the curve of f if x is equal to minus 3, and also find the point where the tangent cuts the curve again. So let me just show you something in the previous question. If I look at this sketch, somewhere if this purple line continues and this green line continues, it's going to cut another place. So I still call it a tangent because at this place it only touches once. But if I extend all the lines, it's going to touch somewhere again, very high, but I can work it out with algebra. So if I make my little list, I know x is minus 3. I can work out what's y, and I can work out what is m. So to work out y, I'm just going to sub in minus 3 in all the x's for the original. So minus 3 cubed, minus, and then minus 3 squared, minus 35 times minus 3, and then minus 50. Luckily, I have a calculator, so the answer for that one is 19. And then to get the m value, I can just sub in minus 3 into the derivative. So firstly, let's get the derivative. So therefore, the first derivative, which I know is equal to m, would be equal to 3x squared minus 2x minus 35. And therefore, m, if all the x's is minus 3, I can just type it in the calculator and see what the answer would be. And the m value is minus 2 in this case. So therefore, y is equal to minus 2x plus c. I now know y was 19 if x was minus 3. Sorry, there's a mistake. Plus c. And then therefore, it becomes a plus 6. I take it over, and that will be 13 is c. So y is equal to minus 2x plus 13. Okay, so now that was only half of the question. Now I must figure out where is this graph going to cut the other one again. And I do that by making the two graphs equal to each other. So I know it touches at minus 3, but somewhere else there's another point of intersection. And that's what I'm going for. So I'm just going to say minus 2x plus 13 is equal to x cubed minus x squared minus 35x minus 50. I want a 0 on the one side, so I'm just going to keep the x cubed and the minus x squared there. If I take over the minus 2, this becomes a minus 33x, and then minus 50 minus 13 gives me minus 63. So this really looks as if it doesn't have a very nice answer, but let's see what we can work out. In this playlist, there's a video on how to factorize cubic expressions. Okay, so I would really invite you to go and just check there. If you have a white calculator, you can use that. But with this one, I can use a bit of deduction skills to then get the answer a bit easier. Now, in this specific sum, I am just going to use the inspection method to factorize. Now, I know it touches at x equals minus 3. So then I can say, therefore, I know that x plus 3 is a factor. I now need to figure out what the others are. Remember this method, I can check what is x cubed divided by x, okay? That I put in the first part of this bracket. So that must then be x squared. Then I also look at what is 63 divided by 3, okay? I know that's a 21. So I can then just say that is going to be 21. Now I need to figure out what this middle variable is. So remember the method. I am now just going to FOIL out everything, or not FOIL, I'm just going to distribute in, and then figure out what the k has to be. So in this case, this will be x cubed plus kx squared minus 21x, and then plus 3x squared plus 3kx, and then minus 63. Now I can now choose if I want to work with x squared or just the normal x's. I'm going to go for x squared in this case, but it's really up to you. And I know the x squares just need to add up to minus 1. So my formula I'm going to write down is kx squared plus 3x squared must equal minus 1 x squared. Now I can take over the 3x squared, and therefore kx squared is equal to minus 4 x squared, and therefore k is equal to minus 4. Now that helps me to then get the second bracket, which I can just factorize. Okay, so I'm just going to take this away, but now you guys know how I got the minus 4. Now I can just use my grade 9 trinomial skills to see this would be a x minus 7 and x plus 3. And therefore, the other x value where it cuts again would be when x is equal to 7. I know the one answer is x is equal to minus 3, but that is not what I'm looking for, so it's not applicable. To answer this question, also find the point where the tangent cuts again. I now need a y value, and I'm just going to get that by summing 7 into my original fx. But if you're very smart, we worked out a tangent, and if it cuts both of those graphs, then I can just sub in the 7 in the tangent. So I'm just going to say this is minus 2 times 7 plus 13, and therefore it's minus 14 plus 13, which would just give me minus 1. So therefore the point is 7 and minus 1. Okay, guys, if the factorization was a bit tricky, just go and watch the other video on the inspection method of factorizing a cubic expression. Question 3, find the equation of the tangents to the curve when y is equal to 0. So why am I saying tangents? Okay, so remember, if they give me an x, there's only one x value for a graph. So if I say what is the answer when x is 2, it can only be one specific point because of the vertical line test. In chapter 2, we taught you that a graph is only a function if every x has only one y, or with the vertical line test, if I move a vertical line from left to right, it can only cut the graph once at a time. But now this specific question tells me it's a y value. So if it's a parabola and I'm saying y is equal to 0, then it has two separate answers, and therefore it would have two separate tangents. Sorry, I'm not Picasso, but that would be my sketch just to express why would I get two answers. Okay, but the method still stays the same. I'm just going to do something twice. So in this case, I don't know what x is. I know y is equal to 0, and I need to figure out what is m in this case. So firstly, if I know y is 0, I can just sub it into fx because fx is y. So in this case, I'm just going to say y is now equal to 0, and I know that I can just put that in the place of fx. So x squared minus 3x minus 4, it's just a grade 9 trinomial, so x minus 4 and then x plus 1. So therefore x is equal to 4 or x is equal to minus 1. I can now update my list and say I have two x answers, and therefore I will have two separate gradients. And remember, I get the gradient by subbing it into the derivative of f. In this case, the derivative would be equal to 2x minus 3. So now I'm going to get two m values. I can say m would be equal to 2 times 4 minus 3, or m would be equal to 2 times minus 1 minus 3. And this would give me 8 minus 3 is 5, and this one would give me minus 2 minus 3 gives me minus 5 in this case. If I have two x values, I also have two m values. So if x is 4, m is 5, or if x is minus 1, m is minus 5. And that would mean I have two completely different tangent equations as well. So for the one, y is equal to 5x plus c. I'm going to sub in the x and y there. And then for the other one, y is equal to minus 5x plus c. For my first case, I said x is 4 if y is 0. So I'm going to say 0 is equal to 5 times 4 plus c. And therefore c is minus 20. This formula is then y is equal to 5x minus 20. The other one, if y is 0 again, minus 5 times, and this x was minus 1, plus c, and therefore this is a positive 5. I take it over, that's negative 5 is equal to c, and therefore the other tangent is just y equals minus 5x minus 5. Great. So sometimes there are two tangents in a sum. Just do your algebra correctly, and then they won't be able to get you out. The last one we're going to look at, question 4. The graph of f, which is a cubic function, has two tangents. Find these equations if the gradient of both of these tangents equal -9. Now, how on earth is that possible? Now, remember, this is a cubic function, and they are just telling me the gradient is -9. So the only thing that I know is that this is a line that is steeply decreasing because the gradient is -9. So it can touch the graph at two specific places, as I'm showing in the sketch. So we need to figure out two specific equations for these tangents. The two specific spots where it would be a tangent to the curve touching once there and there. So that's how I have two tangents to one equation. Let's just do the algebra, and then everything would fall into place quite easily. I know the gradient is -9, but it has two separate x's and two separate y's. Now, normally I would start by just subbing something into the original. In this case, I need to start with the derivative. So the first derivative of x, which would be equal to m, is then equal to 3x squared minus 12x. The 7 doesn't have an x, so it's not part of the derivative. Now I know I'm going to put this equal to -9, and then this thing is going to be a trinomial that I can solve to get two x's. So I'm just going to take the 9 over, and then it is 3x squared minus 12x plus 9. I want to divide by 3 everywhere just to make my life easier, and that's a 4x plus 3, and therefore my grade 9 trinomial skills tells me this is x and x minus 3 minus 1. Okay, perfect. So now I have two x's. So therefore x is equal to 3 or x is equal to 1. I now just need to find two separate y values, and I can find y by subbing a 3 or a 1 into the original. So in this case, y is equal to 3 cubed minus 6 times 3 squared plus 7. And the other one, y is equal to 1 cubed minus 6 times 1 and then plus 7. My calculator tells me this is going to be minus 20. And the other one is quite easy. It's just 1 plus 7 is 8, minus 6 is 2. Okay, great. So now I must just put the correct ones next to each other so that I don't make a mistake. So the first one, if y is equal to minus 9x plus c, I can sub in the minus 20 as y and then the 3 as x. And therefore, I can then see it's minus 20 and then plus 27. So this would just be 7 as c. So y is equal to minus 9x plus 7. Now I can just do the other one. I can just see 2 is equal to minus 9 times 1 plus c. I take the 9 over. This becomes 11 as c. And therefore, y is equal to minus 9x plus 11. Okay, great, guys. That is how you find the tangent in the calculus chapter. I hope it made sense. There were a few new concepts. Just go back and slowly rewatch it if anything was not clear, or leave me a comment if I need to make a separate video on something that you misunderstood.
If this video helped you, please like and subscribe.
JMath.